Hello everyone, welcome to Pepcoding. So in this series of dynamic programming, today we are going to look into our first question, that is Fibonacci-dp. So we have already solved this Fibonacci question in recursion series. Just in case if you have not seen that video, please I'll recommend you to go and watch that video. Now to just give an overview of what is Fibonacci and how we used to solve in a recursion series, let's see. So first we will discuss what is this Fibonacci series. So Fibonacci series, or let's say Fibonacci sequence, is nothing but a sequence of number where the first two digits are always fixed. Those are 0 and 1. Okay, so let's say this is element and this is its indices, that is index. So at 0th index always 0 is present, and first index, that is at index 1, 1 is present. Now for index 2, the element that is presented in the index 2 is sum of its previous two elements. That means at index 2 the answer is of index 0 plus of index 1, element at index 0 plus element at index 1, that is 0 plus 1, that is nothing but 1. So at index 2 1 is present. So similarly we can say that at index 3, 4 and 5, we can say that for 3, 1 plus 1, that is previous two elements, the sum of previous two elements is the answer that is going to be stored at this index, that is third index. So that is going to be 2. For 4, at index 4, what will be the answer? It will be 2 plus 1, that is 3. For 5, it will be 3 plus 2, 5. For 6, let's try to solve it. 6. Let's try to see what is going to be stored at 6, but using some formula. We're using a generalized formula. So here we can see that the generalized formula can be created as, for f of n, for Fibonacci of any given n, can be represented as Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? So this is the formula. So let's try to use this formula for 6. Let's say f of 6 is equals to f of 6 minus 1, that is 5, plus 6 minus 2, that is 4, right? So f of 5, we know that at the 5th indices what is stored? 5 is stored, and at 4th indices 3 is stored. Therefore the answer is going to be 5 plus 3, 8. Let's try to see that if it is correct or not. For this, for 6, sum of these two elements, let's say 5 plus 3, 8. Therefore this formula is a generalized formula, which means it can be applied or it can be used over any element in the Fibonacci sequence. Now let's try to do this, let's try to write a code of this recursive code for this Fibonacci, and then after that we will discuss that what is dynamic programming and how it is good or how it is better than recursive approach. So here we know that what we are going, but before that let's do the dry run. Okay, so that will be more clear to you all that how you are going to do. Let's say element is 4 and 4 has two calls, that is, what are those two calls? N minus 2 and n minus 1. 4 give a call to n minus 1, that is 3. It gave call to n minus 2, that is 2. Again 3 gave call to n minus 2, that was nothing but 1. And it gave call to n minus 1, that is nothing but 2. Again 2 gave a call to n minus 2 and n minus 1. Here it will be 1. Here it will be 0, right? Because 2 minus 2 is 0. From 1 we also have two calls, that is n minus 1, that is 0, and n minus 2 minus 1. So here we can say that this is a negative base, a negative condition. Therefore there is no need to reach up till here. We have already seen this in recursion. So therefore when I am at 1, that is when I encounter 1 or 0, I know that when I encounter 1 or 0, I have to return what? For 0 I have to return 0, and for 1 I have to return 1. because the first two elements are always fixed. Therefore, from here, what I'll do? From 1, I'll return here 1, and from 0, I'll return here 0. Therefore, 1 plus 1, because we are doing what? N minus 1 plus n minus 2, right? Therefore, 1 plus 0 is going to be 1. Therefore, n minus 1 call of 3 gave us answer 1. Now for n minus 2, this will also return us what? 1. We have already seen here. Therefore, 1 plus 1 is going to return 2. So here we can say that for 4, there are two calls, that is n minus 1, and we have to add this towards n minus 2, right? So here we can see that from the n minus 1 call of 4, we got what? We got an answer of 2. Now we have to add it with n minus 2's call. Now what is going to be n minus 2's? So what is this n minus 2 going to return? This n minus 2 is going to return what? Let's see. This 2 will again make 2 calls. That is going to be n minus 1 call, that is going to 1, and n minus 2 calls 0, right? Therefore, is that okay? So from here it is going to return 1, and from here it is going to return 0, and this is going to return what? This is going to return 0 plus 1, that is 1, right? Therefore, this is going to return nothing but 1, right? 1. So here we, with this tree diagram, we can see that from the n minus 1 call of 4 and from the n minus 2 call of 4, we got 2 and 1 as the answer, and this is equal to 3. Let's see that for 4, is the answer 3 coming or not? So here we can see that at the 4th indices, the answer or the element that is stored at the 4th indices is 3. Therefore, this tree diagram is correct, right? So what are the base cases that we can see here? These are the base cases, that is 1, 0, 1 and 0, right? These are the my base cases, because from 1 I have to return 1, from 0 I have to return 0, because the first two elements are always fixed, right? So let's try to do this in code. So first, let's return Fibonacci of n minus 1 plus n minus 2, right? And what are the base cases? If n is equal to 0, return 0, right? And if n is equal to 1, do what? Return 1. Let's try to run this code, and it is being accepted. Now we can see that it is being accepted, okay, for this test case. But now if we try to submit it, we'll see that it is going to give us some error. Wait, I'll show you. Okay, here there are some test cases failing, but what is the reason of test cases being failed? The reason is cleared over here, that is time limit exceed. I don't know if you are able to see. Okay, yeah, now you are able to see. The reason is because of time limit being exceeded. So what is actually happening here? We can see that if we try to notice that, we can see that this 1 for n is equals to 4, 1 was being solved how many times? 3 times, right? Even though we know that the answer from 1 is going to be same, that is, if we reach at 1, we are going to return 1, and if we reach at 0, we are going to return 0. Then also we are solving again and again, right? We are solving that problem again and again. Similarly, we can see that if this 2 is being solved here and here, therefore the 2 is being solved multiple times. The same function is being solved multiple times, even though it is going to give the same answer. Therefore, this is actually what it is doing, that it is doing nothing but consuming my time. That is, it is traveling the same path again and again, even though he knows that, or we know that the answer, the destination is going to remain the same. Therefore, to avoid this situation or to avoid this thing, DP was introduced, dynamic programming was introduced. So what it was, what we say that if I'm going to travel the same path, then when I travel this that path for the first time, I'll store that answer. Okay, and whenever I need to travel the same path again, I'll just directly fetch the answer. Okay, I'll directly fetch the answer that is stored on the same path. Therefore, I don't have to travel that path again and again and recalculate the things. Okay, with this, let's see what is meant by DP. So there are actually 3 stages of DP. First stage is storage and meaning. In this stage, what we do, we create a storage where we are going to store our answers for the functions. That is, if we are going to travel through any path, we are going to store it, and if required in the future, if we require to travel that same path again, we'll just directly fetch that answer from our storage. We don't have to again travel that path. Okay, so with this, first stage was storage and meaning. Second stage was direction of problem. We have to identify that in which direction we are going to solve the problem. Okay, and third is travel and solve. So with this, let's see first thing, that is storage and meaning. So here for n is equals to 5, we are going to create a storage of n plus 1 size, that is 6 size. Why? Because indexing is starting from 0 and we have to go till 5. So if I want to go from 0 to 5, I have to create a storage of 6 size, that is 0, 1, 2, 3, 4, 5. Let's see, 1, 2, 3, 4, 5, 6. So the storage is being created of n plus 1 size. Okay, whenever I have to go till some number and I have to go from 0, I have to start my indexing from 0, I have to create my size of n plus 1. Okay, so with this, let's create a storage of n plus 1 size. Let's say this is our storage of 1, 2, 4. Okay, 0, 1, 2, 3, 4, 5. So we are going to solve this for n is equals to 6. We are looking for example of n is equals to 6. So n is equals to 5. Okay, therefore we are creating storage of size 6. Now with this, what is the second thing? We have to see the meaning. What is the meaning? What is the meaning of this cell? Let's say we are standing at this cell. Okay, we are currently at this cell. So what is the meaning of this cell? This cell means that it is going to store the respective value in the Fibonacci series at this index. What it means? It means that if it is at this position, then it means that it is going to store the respective value. For this question, it means that for the Fibonacci sequence, it is going to store the respective value of that indices. That is, for 4, it is going to store what? It is going to store 3, right? We have already seen this. So therefore, this is the meaning of this cell, that is, it is going to store the respective value of the Fibonacci sequence. Okay, now second thing is direction of problem. We have to now identify the direction of problem. So here we need to identify where is the small problem and where is the big problem, and then we have to travel, or then we have to go from small problem to big problem, or start travel and solving this DP, and we have to fill this DP, right? We have to identify small and big problem. Now there is another definition, or there is a simpler definition which defines the direction of problem, or which is helpful to understand what is meant by direction of problem. That definition means that if an entity, or if a cell, or let's say this is a cell, this is a cell, this is also a cell, this is an individual entity, right? This is a cell of indices 2 is an individual entity. So therefore it means that if an entity in the storage is dependent on any other entity, then it has to be solved first. That means, let's say in Fibonacci, this is my cell, right? 0, 1, 2, 3, right? We know that first two elements are 0 and 1. Now this second indices and this third indices, this second indices is dependent on these two, right? And this third is dependent on these two, right? Therefore storage, or sorry, direction, to identify the direction of problem, we can say that if, let's say, 2 is dependent on 1 and 0, then we should solve 1 and 0 first, right? So what this means, it means that if an entity is dependent on any other entity, then that other entity must be solved first, then I will be solved, then we should solve this current position. I'll again repeat myself. Let's say if we are at 3, then to know the answer of 3, or to solve to get the answer of 3, I must know the answer of 2 and I must know the answer of 1. Therefore this is 3 is dependent on 2 and 1. Therefore before solving 3, I have to solve this 2 and 1. Okay, so with this I hope that this definition is also clear, and using this definition we can identify where is the small problem and where is the big problem. So for this question it is really easy. We can say that small problem is here and here is big problem, because we have to solve for n is equals to 5. We want to get the answer for n is equals to 5, right? Sorry. Okay, now what we are going to do now, we know the direction, like we have to go from this direction to this direction, and we have to keep on solving. Now what we are going to do, we are going to do nothing but it is going to be same formula, that is n minus 1 and n minus 2. Now here we know that first two elements of dp are always fixed, that is 0, 1, right? Now we also know that the sum of these two is going to be stored at second indices. We can directly store it here only, that is 1, right? 0 plus 1. Now what we will do, we will start filling our dp from this position, that is this point, okay? And we have to okay, now we know that we have to start filling our dp from this point, and we have to fill till what? Till n. Therefore what we will do, we will just use those two calls only, that is n minus 1 and n minus 2. That is, we are going to pick answer from these two points, that is we are going to fetch our answer of these two, and we are going to directly add them, that is 2. Similarly for 4, we are going to use 3 and 2, that is 2 plus 1, that is going to be 3. And for 5, it is going to be 3 plus 2, that is 5. So here we have already seen that the answer for 5 is 5. So with this, I hope that this was really simple. So I hope that these three things were clear to you all. Let's try to code this thing. Okay, let's try to code this thing, and let's try to see that how it is going to give us the correct output. Here we can see that the test cases were failed. Let's try to download those test cases. So just in case, for 43, okay. Okay, for 43 expected for 43 the number was given n is equals to n as 43. For that, the expected output was, you can see that this was the expected output, but what we are getting, we were getting an empty, where is it, we were getting an empty answer. Therefore this means that the time given to us was being exceeded. It is already shown that time limit exceeded. Now let's see how this is going to be handled by dynamic programming. I'll just comment this part and let's start. So before doing this, what were the steps? We remember the steps. The steps were, okay, there were 3 steps. What were those 3 steps? First was to create storage, right? So we are going to create the storage. We will name the storage as dp, and this is going to be a list of how many of what size, of size n into 1, sorry, n plus 1, right? This created my storage. Now I have to pass this in my function, right? So I pass this and I have to catch here. So here is being catched. After fetching, what was the next step? Second step was nothing but to identify the direction of problem, right? Okay, and the third step was nothing but travel and solve. So for this problem, our direction of problem is going to be nothing but same, that is for I in range. But now before doing this direction of problem, before running this loop, we remember that what we have discussed. We discussed that the first 2 elements of a Fibonacci series are always fixed, that is 0 and 1. So let's directly store those 2 values. Insert at 0, it was already 0, right? And similarly for 1, it was 1. Now addition of these two, 0 plus 1 is all is going to be 1. Therefore at 2 we will directly store 1. Now with this I have to run my loop from where? I have to run my loop from p to n plus 1. Okay, now what we have to do? We have to use those 2 calls, that was n minus 1 and n minus 2. So we will directly do that. Insert at I, we have to what insert? We have to insert the answer of I minus 1 plus the answer from I minus 2 position, and that is it. And now we have to return, that is our answer is going to be stored at where? At nth position. Now let's try to run this code, and it is being accepted. Let's try to submit this code, and all the test cases are being passed. So why this is happening? Let's discuss it in short. This is happening because whenever I am reaching at this 1, I am directly storing that answer, that is this is my storage, right? Let's say this was my storage. For 1 I have for 0 I have already stored 0, right? For 0 I have initially stored 0. For 1 I stored 1. Now for 2, whenever I reach at 2, instead of solving 2 again and again, I am just picking answer from here. That is, first I have to solve at least one time, that is for 2 I have already stored 1. Now whenever 2 is encountered again, like this 2 is encountered again, I can just fetch my answer, or I can just take my answer from this position that was inside an array or inside a list. It was already stored, therefore I can just take my answer from there. So this is what is happening in DP. So these are the 3 main stages, and throughout throughout this series we are mainly going to use these 3 stages only. So I hope with this these 3 stages were clear to you all, and let's meet in the next video. Thank you.